studied air pollution I've studied air pollution my whole entire career, over 30 years. And specifically, I've spent most of my career, interestingly, looking at aerosols. And that's the haze that you can actually see, the smoke and things like that. And that's been kind of, that's is kind of was you didn't hear much about aerosols when, until COVID. And then people kind of started realizing, oh, aerosols, they're things that viruses are carried in. They're more than just something that comes out of a spray can. And in this project, I've had to sort of shift over and start thinking about gases, toxic gases, and other pollutants in our atmosphere, because of the crazy mixture that is coming out of this particular river. So air is, sort of the underlooked exposure pathway for our health, which I always say this, and every time I say it, I can't believe I'm saying it because, it is the number one route of how things get in our bodies. And we worry about, everything we eat and everything we drink, but we inhale 11,000 liters of air each day and we don't filter it. It's filled with pathogens, it's filled with toxins, it's filled with, carcinogens. And no one seems to care, or people care less, and we understand far less about it. And so there's an estimated I think closer to 8 million premature deaths per year worldwide attributed to the air pollution that we're being exposed to. And I would say that that's probably an underestimate because that's just looking at sort of what we call the criteria pollutants, the things that we always think about as air pollution. And now there's all these new pollutants, and I'll talk more about that today. But there are more deaths due to this air pollution than HIV, malaria, and tuberculosis combined. And the bottom line is 90% of the world is breathing unhealthy air. And so it's a challenge to figure out what the air is doing to us. It can do more than just affect our lungs. It affects our hearts. Basically, anything you inhale can get into every single organ in your body, including your brain. And so, there's these what we call acute effects. That's like what you feel right now on sort of short term, short duration. And that's sort of the coughing and, throat irritation and the asthma. Those are kind of sort of immediate responses that your body has to these pollutants. And then there's long term, and that one's really hard. Basically, it's typically much lower levels, but it's every day you're breathing this. And that is a huge part of what we're dealing with down in South Bay. They're breathing high levels, don't get me wrong, but they're also every day breathing pretty high levels, which is, of major pollutants that they should not be breathing. And so, in particular, some of these are neurological agents, hydrogen sulfide gas that I'll talk quite a bit about. It attacks your, mitochondria, attacks your brain, it attacks your nerve system. And especially for kids, this is a deep, deep concern. And it can lead to dementia and, all these other things that like aren't normally associated with air pollution, but they are really important. And so there's a lot of reasons to think about, why we should not be nobody should be being exposed to, especially what people are breathing in South Bay, San Diego. So there are new challenges that we're facing because of all the humans that are on this planet. We're just pumping more and more pollution into the air, into the water, into the soil, and there's nowhere to really hide it. People honestly have been trying to hide it in the water for a while. In this talk, I will describe why that's not simply just not working. I think a lot of people think if you pump pollution like sewage outfalls into the ocean, it's just gone. The classic statement, dilution is a solution to pollution. Well, that's not true, especially in this case. But the point is, we're starting to see like a lot more pollution get washed into waterways. We're seeing wildfires. We're seeing urban fires. So things are burning that have never burnt before. So like new components are going into the atmosphere. And, basically we're starting to see effect. It's even having an effect on our weather patterns, where and how much rain falls. We're seeing drought in some places and flooding in other places. And the thing that I'm going to focus in on today is sort of the most understudied pathway, which is the water pollution, the water to air transfer pathway. So this has become such a big thing that I was constantly being asked, is the air healthy, especially after the fires in LA? I get called by everybody. How can we protect ourselves? Should we go outside? Should our kids go to school? And I was finding it harder and harder to answer this simple question. Is the air, I thought it was simple, sounds simple, is the air safe? And, but the problem is that there's just so many things that are in that air now that weren't there before, and we don't know. There's no health studies on these things. And the hardest part is that it's this mixture. It's all this stuff. It's not just one pollutant, it's thousands of pollutants, including things like heavy metals, viruses, bacteria, that entire mixture. Nobody's done studies to see. I mean, we kind of are. We're doing them right now on humans in the real world, but that's not a good thing. The common things that are measured, when you look on your phone, you'll see sometimes this thing called the AQI, Air Quality Index. You see that here. It's color coded. It tells you whether the air is good or bad, and they can forecast what it'll be like tomorrow. And basically, this is just it's only focusing on ozone, carbon monoxide, sulfur dioxide, and particulate matter, different sizes. So it's not looking at the things that are the worst things for you. It hasn't even started to look at that, because nobody knows, as we'll talk a lot about towards the end, nobody knows what to set as regulations for these things. So this is where things stand from an air perspective and how it's affecting our health. Challenges are increasing, sadly, especially in the United States, where we're rolling back all of our environmental regulations. I don't want to dwell on this too much, or I can't, I find myself not able to keep going, because it's overwhelming to think that, like, right now, when we have the most pollutants in our environment, we're weakening our regulations. And so even, we're sort of being forced to be the ones to measure things when these big incidents happen. We unleash all of our measurements. We help other people in other parts of the country figure out what they should be measuring. And so we're having to regulate or figure out things to protect people ourselves as citizens, which is not the way it should be. So as I say, I've studied aerosols my whole career. And this just shows aerosols and how they actually circle the globe and get taken into clouds and affect storms. And, basically an aerosol can be released, such as dust or sea spray, can be released on one side of the globe and go all the way around. It takes about 2 weeks. And lots of examples, I say dust and sea spray are two natural types, but there's all these different forms of pollution from combustion and other sources, as well as bioaerosols, as we refer to viruses and bacteria, which got a lot of attention during COVID. I was the one that convinced Fauci that SARS-2, the virus responsible for COVID, was airborne. And so I put a lot of time. I went toe to toe with WHO and CDC. There was a group of us, global group of us, that fought hard. And I will say that sort of prepared me for the fight that we've been having in the South Bay. It's just, I don't know, some of us just, if you see something, you say something, and, something like this is affecting your health, people need to speak up. So as was mentioned, I directed the Center for Aerosol. It's a huge National Science Foundation direct center for nearly 15 years. It's a $40 million center, and it looked at specifically at aerosols and stuff that gets out of the ocean. And it became more and more about, what pollution gets out of the ocean. And that's what sort of led me into thinking about, this is how I'm giving you sort of the background of how the heck did I end up doing this in the South Bay. But what we did in this center was we realized that nobody really knew what came out of the ocean, even though it covers 71% of our Earth. And so we said, okay, we're going to build the whole ocean system with the atmosphere, with everything in the lab, and we'll pump seawater into it, and we'll study things in an isolated way to try and understand this massive source. And so that's what we did. And we were very successful at doing that, just to understand this one, as I say, the largest source, but the one that was by far the least understood. And in particular, we were interested in looking how it affected climate and clouds. It has shifted over, as I'll talk about today, more and more towards how it affects health. So thinking about this, how do you produce the ocean in the lab? Sounds like most people were just going and taking salt, sodium chloride. It's very salty, right? But there's so much more in the ocean than that. It's filled with life. It produces over half of the oxygen we breathe. It is a vital part of our Earth system that is trying its best to keep things in check. And it is absorbing a huge hit, the largest hit of the heat we're feeling right now, as we're seeing in the ocean temperatures. But just thinking about this, one drop of seawater contains millions of viruses and bacteria and all the signs of life, up to 10 to the 15 different organic compounds. I mean, it's just incredibly complex. And so we wanted to produce this in the lab, and we did. And so this just shows the latest incarnation. I'll show a video of it in a second, but it's called SOARS. This has 36,000 gallons of seawater in it. And we pump it directly into our facility at Scripps. People can come visit if they would like. And we can control everything. We can make hurricane force winds. We can study the effects on clouds. We can look at reactions. We have total control of this massive system. We can even make sea ice. So we can simulate oceans from all around the world. So this just shows a picture where we sort of view things. We work with oceanographers. We really try to understand the physics of everything and how the chemistry and the physics and the biology all are affecting things. We can make, the nice thing we like about it is we can make a change and induce a change and then see a response. In the real world, there's like 50 things happening at once and you never really know. So we can look at all of these things. And so as I say, if people are ever, nearby and want tours, we give tours. It's a massive facility. It's really impressive to see, but it's what's set us up to be able to answer this question about pollutants that are getting out of the water and into the air. So this just shows a video. It's in this one big facility. These are light pipes that bring the sunlight in. This is Scripps, and this is the system. This is the big, massive wind tunnel. So I say that can give you these huge winds. This is the breaking waves. You can see if you look really quickly. And my group doing measurements. And so it's just like we do when we go out on a ship, except we can say we have sort of the control in the lab. So this gives you a feel for, for this system, how big it is. This is the breaking waves. We can control their magnitudes. We can control everything and measure everything as we watch. And so a big part of what we've done with this system is look at aerosolization and how when those waves crash, how viruses, bacteria, pollutants, gases all can get released. And so when a wave breaks, I've fallen in love with bubbles. You can see there's bubbles, lots of bubbles. I know everything about bubbles now, more than I ever thought I would. But those bubbles burst. And there's a couple of mechanisms that cause this rupture to happen. And you can see the drops, you can see the spray, and that gets out and that contains these pollutants. And these pollutants can be heavily enriched, up to 100,000 times higher than they are in the water. So it's not just salt, it's all this other stuff. And when you live in a coastal environment, as we do, as many people do, and you have a polluted ocean, we are now starting to see heavy loadings of different pollutants, as I'll talk about today, that are getting into the air. And so we've worked really hard to try and understand these processes. So on the left, it shows sort of the work we did on understanding sort of the natural system biology, how it affects what gets out. And, this is what case our center did for a very long time. But now think about South Bay. We got done and we thought we need to look in the real world and see what we see. But the South Bay becomes really complex because you've got all of these other things, insecticides, pesticides, wastewater, heavy metals, everything, agriculture, DDT, like all these things are getting dumped into the ocean down at the border and at other places along the coast because there's sewage outfalls all up and down the coast. And so the question becomes what gets out and how far does it go? And how is this disrupting our climate and our clouds and our health is the big question that we've been trying to explore. So we didn't have to move far to start looking in the real world for these effects. We had this huge issue that, as everybody knows, I think on this call, down at the border. And we'd been working on this problem, as I say, since 2017 and looking at viruses and bacteria. You know that we do sewage surveillance. You've heard wastewater surveillance when we want to understand diseases in a certain area, how much SARS-2 is in a certain area. We can just look at the wastewater. Well, what if this wastewater is getting into the air? Excuse me. So this had always been a water crisis. It had always been, excuse me a second. It had always been a situation where just don't go to the beach. Don't go in the water. Don't go surfing. But if it's in the air, you can't really tell people, you can't hear you shut down the beach. You can't really tell people don't breathe, right? But the amount of stuff that gets into you from the air, regardless of whether you're at the beach, regardless of if you're 10 miles inland, is high, much higher from the air than from that water. So everybody's being exposed to this stuff. And so I quoted, 11,000 liters of air a day is how much you inhale versus 2 liters of water, and you filter your water. So this was sort of when people started thinking, if it's not just a water crisis and it's starting to affect me and I don't live at the border, what could that be? You have a question? Is there a question? Okay. 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 So just to give you a flavor for sort of this region, I think I don't know how many people are familiar with it, but 3/4 of the world lives within 30 miles of an ocean. Even high, like high fraction lives near lakes and rivers. These are all potentially polluted sources. This is a South Bay. This is Imperial Beach, actually, a street after Hurricane Hillary. And that's raw sewage floating down the street in the middle of a California town. And so we started looking up and down the coast. So here's the border. You can see sort of where we are. Tijuana's down here. This is the Tijuana estuary region. We also sample sort of clear up 20 miles north at Scripps where we are. We sample off the pier to kind of get quote background, although now we're starting to realize we see things even that far. But what we do is we collect both water and air samples all up and down the coast and all across the region. And one of the things we studied was, does it get out? Do these viruses and bacteria make it into the air? And, we worked with oceanographers early on. You may have seen these pink dye studies where they released pink dye into the ocean to see how far it went. And what we found is that if it gets trapped in the surf zone, it gets into the air. It's because of the waves. It's that breaking, it's that aerosolization. So we've had a very strong focus on the ocean until this study. We still are looking at the ocean, but we had a big surprise when it got to this particular problem. So this just shows a better picture of where the Tijuana River empties into the ocean. This is the Imperial Beach Pier. And so this is my team, basically sampling from the pier. And as I say, we always collect water and air samples because the goal is to understand this connection between water pollution and air pollution. So one of the first things we were able to show, which shocked everyone, including ourselves, we started doing sequencing like we did during COVID. And you can do genomic sequencing and you can link what is in the water and see if that is the source of what's in the air. And we found that up to 76%, nearly three-quarters of the bacteria that you were inhaling in Imperial Beach come from that polluted Tijuana River. And so basically, this was a much higher number than any of us expected. And so then, we started thinking about this. Okay, so that's the biological component. We're now doing the viruses as well, looking for things like SARS-2 and, other type norovirus and other types of pollutants that you probably don't want to be inhaling. And we found things like phage. And for people who don't look at wastewater like we do now, phage are like one of the best indicators of wastewater. And they've never been detected in an urban environment, except they are being released in the air down in the South Bay. And so the big question is, okay, that's the biological stuff. What about the chemical stuff? Well, it's all in that water because, especially from a usage perspective, there's things like cocaine, methamphetamines, heroin that are all in that water. Now we are seeing fentanyl and all of these chemicals, including pesticides and sunscreens and, all these different chemicals that are common in wastewater are actually in the air down in that region as well. So we published the first work on the bacteria in 2023, and then we published this work on the chemical side in March of 2025. All right, so now we're going to get to where we are now. And so we've been doing this work. That's the background. We were looking at aerosols. Has been my area of expertise. And we've always been going during the wet season when it's raining. We'd never gone during the dry season because there shouldn't be a river, but there was a river. There has become a river even during the dry season. When we arrived in September or August of 2024, there were between 40 and 80 million gallons a day of pure wastewater flowing through that river and emptying into our Pacific Ocean. That's just shocking to me. And nobody cared. Nobody was doing anything. And the community was screaming their heads off that that they were being poisoned. And, honestly, they probably were and are. And so there were this system got set up by the Air Pollution Control District that you could report the odors, and it hit record numbers. One thing I want to point out is odor is not aerosols. Aerosols don't smell, but gases do. In particular, one gas really smells, and I'll talk more about that. And so the question became, what are the gases that are causing all of this toxic air? And you can see it on even just things like copper. If you have copper, any copper you leave out, basically overnight, it's black the next day. That's how toxic the air is down there and caustic it is. And that's what people's lungs were feeling. And nobody was listening. So we turned on our instruments. We bought an instrument that targeted the stinkiest gas, hydrogen sulfide gas, which is a toxic nerve agent used in World War I. And we basically started looking for it. And we went to our normal spot. We have a mobile air quality system. We went to the ocean like we always do. And this is kind of complicated, but basically we looked at sort of wind direction and wind speed. And what you see is when the air was blowing from the west towards us from the ocean, there was blue, which means not much hydrogen sulfide, but we saw it coming from over land, which was a real head scratcher. And so we talked, my students were very astute, talked to the community, and the community's like, why are you over there? The smell is over here by the river. We're like, the river? Like, there's just, nobody envisioned that a river could create this much of a problem. And we found the highest hydrogen sulfide levels right at this one spot that has now become the infamous, what we call the Saturn hotspot, which I'll talk a little bit more about. But hydrogen sulfide is a source of, rotten egg smell. I'll say up front, it is just one gas out of thousands that we detect coming out of that river. So this shows the region. Here you see a shot of the Tijuana estuary region. This is Imperial Beach in this part that butts right up against it. And this is a community in San Diego, Nestor community, San Isidro's right here. And this is a picture of the hotspot blown up. And you can see white right there, right? That is from space. There's so much of this white foam. That's not normal. That shouldn't be there. This is where we started, was at Borderfield. And as I say, then we gradually moved up and started moving inland, and we found this massive spot where things were coming out. So here's the hot spot zoomed in. What happens is there's a place where the river flows in from Mexico, because say millions of gallons a day. It can be over 1 billion gallons a day. So when people tell you that the spill in, Washington of 200 million gallons was a record, they can get to over 200 million gallons in a day. So no, it is not a record. This is the record, and this record is being beat every single day. And so we say that this time of the year, this is just pure wastewater. So it's raw sewage and industrial waste from these factories on the other side that you hear very little about, called maquiladoras, and we can talk more about that. Many of these are US factories dumping whatever they want into that river. So it's this incredible mixture of compounds. And so you can see, again, from space, you can see the foam. And so we set up near this hot spot. This just shows the water coming out. And, it's all kinds of colors. It can be black, it can be blue, it can be turquoise. And so you can see, this is what's leading to the release of the gases. It's this turbulence, it's these bubbles. So bubbles tend to aerate things and get more of the smell to come out here than anywhere else in that whole region. So again, this is just my students. We wear biohazard suits when we sample because, you just don't want that water to touch you. I still have a skin infection from 2 years ago. These are our air samplers, and we, sample very carefully all over to get the samples that we've been running and that I'll talk about today. All right, so here's what woke people up. And this is our hydrogen sulfide measurements at the farm in Nestor. So we decided rather than being right next to the river, we're about a half a mile from the river in a community, because we want to see what communities we're being exposed to. And I will tell you that the gas level concentrations fall very fast as you move from the river to this particular spot. So in a way, that's a good thing, but the levels are still ridiculously high. So this just shows hydrogen sulfide concentrations in red. And what you see is these spikes. And these spikes are every single night, starting September 1st. and they started getting higher and higher and higher. So you might say, okay, what is 4,000 ppb, parts per billion, of hydrogen sulfide? Like, what's normal? Normal is like a tenth of a part per billion, far less than 1 part per billion. And they're breathing thousands of parts per billion. This is just not okay. And so we started seeing it. This was, sort of the beginning. We became concerned. We realized, this was a problem much more than we had envisioned. And so I did a presentation to a task force that was, concerned about this issue, as well as San Diego County Human Health Services, on September 5th. So that was kind of like right here. And nothing was said. Nothing was done. And so we're like, this is really bad. Like, my normal way as a scientist is I would publish it. I'd wait. It'd be published in a year or so, but this couldn't wait. And so the mayor of Imperial Beach at the time, Paloma Aguirre, said, let's have a press conference. Let's just announce it, because these people are breathing really bad stuff. And you can see that it was just getting higher and higher and higher by this time. This is the 9th. September 9th is right here. And that's when it hit the highest levels, 4,500 times higher than, typical levels. And so we had this press conference on September 9th. And on September 10th, magically, the wastewater was diverted. And by that, I mean, a pump was turned on, which we still don't understand these pumps or completely. But a pump was turned on and the water was diverted from the river. So it was no longer coming across the border. It was being held in Mexico. We learned later that it is being sent into across sort of the border region, and then it dumps in at a location called Punta Bandera, which is about 10 miles south of the border. It gets dumped into the Pacific still, but much further from this location. All right, so this is one of the coolest atmospheric chemistry experiments I've ever done. If not, it's probably the coolest in my life. It's not something I planned, but hey. So basically, one of the things about it was that we had said we were trying to understand this. No one's ever shown this for any gas, for any pollutant, from any river, anywhere. So we're scratching our heads a little bit, but we're like, okay, why is it there? It's because of the turbulence, right? And so we read papers about wastewater treatment plants, and we learned from that. And we came up with this hypothesis that it must be that turbulent hotspot. It must be where all those bubbles that you saw were. And so what happened when they turned it off, which they said they couldn't do? So we kept our measurements going, and we got to test our hypothesis. And what happened was, it's gone. This is the diversion. It didn't go to zero, but it went way, way down. And the only thing that changed was they turned it off, so there wasn't all that turbulence at that hot spot. So, this was an incredible sort of test. But then how do we link this to what people were saying? We plotted the odor reports against our hydrogen sulfide, which is now black. The odor reports are in red. And what you see is that they track each other. Perfect correlation would be 1. The correlation here was 0.92. So basically, the people were the sensors. The people who'd been being essentially gaslit and told there's nothing, nothing going on, don't worry. They were being completely dismissed. And we basically showed with scientific measurements that what they've been saying all along was true, and it tracks incredibly well. And so this was a very rewarding measurement, because this kind of meant they couldn't continue to ignore the people. So this became very pretty well known. I felt like I was speaking about it every day. We did a lot of press conferences. I did a lot of testimony testifying on it. And it did light a spark, more than anything I've seen move this fast. But I will say right now, and as I will finish tonight, we can talk more about it, we're not done, not close to done, but it did have an effect. I think largely because once we showed it was in the air, then more people realized they were being exposed to it. So it was their problem too. It was everybody's problem. So CDC came in, a lot of different health studies were done. I will add, this is like right at the hot spot. People have, put things to sort of point it out, because it still was so terrible, and, people are birding riding horses. The goats that are in the region haven't had babies in like 7 years. And, it's just unbelievable to me, to us, to this day, that this is, United States. This is California. Just unbelievable. So it got ranked as the second worst river in the US. I would argue that air is the worst air in the United States right now. That's not much, but it became very much. I've met the scientists who sort of uncovered the Flint, Michigan crisis. This is way more than the Flint, Michigan. Not to belittle that because that was serious, but this is even more because it's so many more metals. It's PFAS, forever chemicals, toxic species, carcinogens. All of these things are coming out, and no one is stopping it. So, we published the paper in Science, which is the highest, best journal you can possibly get. It's very difficult to get a publication in Science. So that gave it the gold stamp of approval, but it really showed the power. I was very proud of our team for working with the community, working with the local. There are really good people that care from the political perspective, the policy perspective. There has been a big shift. At first, it was very painful. I won't lie. I mean, I was under fire. They would have liked me to just go away, but I didn't and I won't. But one of the coolest things is like they put up toxic air signs, just like the beach signs. I think these are the only toxic air signs in the whole world that warn people, so they're not just walking into it, sort of blindly and getting exposed as much. So where are we today? This shows the entire time. This is the world's longest time series of hydrogen sulfide. I'm a geek, right? I'm a data geek. So I'm very proud of this figure. It shows since September 1st, these high spikes are the compressed version of what I showed you. So, because it's a much longer time series, it goes to July 15th. You're getting the latest, greatest data. And you hear about it all the time. You can go look up the stories on the news. They're saying it's better, it's going to be better. You hear all kinds of things. Is it better? I keep getting asked, is it better? And like, why does it come and go? And that's the point. Like it comes and goes. What is the worst situation? The worst situation is dry season when it shouldn't be a river, when it's not a river, when it's wastewater. And it turns out those pumps continue to be problematic. The worst part is the pumps are not controlled by the US. They're on the Mexican side. We don't know. They won't tell us when they're getting turned on and off. But from our air measurements, we can tell now. We know that based on what's in the air, we know when their pumps are working, when their pumps are partially working, when they're turning off their pumps. They turn off their pumps to reduce the amount of debris that gets in and damages their pumps, but then they never turn them back on. So what happens is you get these huge, like this is the biggest buildup of all. This was in April and May of this year, got to be ridiculously high again. We reached over 4,000 again. It got just as bad. But like when it sounds the worst, when it's billions of gallons of flowing water, that's mostly diluted rainwater, and we don't see as much. So even though it sounds worse, because it's not just this concentrated goo, we don't see as much. So the worst situation is dry season when there shouldn't be a river. So if there was some way to just not have the river flowing when it shouldn't be, that is a solution. But we don't control the blasted pumps. And so that's something that I'm pushing and pushing. In fact, I'm going to Tijuana tomorrow, talking to Mexican officials to figure out what can we do? Because there is a pretty easy solution in this regard. This is kind of a messy figure, but I don't know, for those of you who are data geeks like I am, this shows every single day since September 1. It's color-coded by whether it exceeds the health standards, because that's what we care about, right? Who cares what the levels are if they're not a concern? Well, first of all, the health standards are being reevaluated. There's a new bill in California that's under evaluation, AB 58. That's just for hydrogen sulfide, and that's what this focuses on as well. But it's every day, and it's related, like the colors, it's got a lot of information, but I just want to draw your attention to down here where I said it was really bad. This is March 2026. You see that every single day was exceedances. And so this is the river, and we started doing measurements at the coast as well. What we've seen is that the pollution from the river, this overall pollution problem, has spread out in time. Now it's many more hours of the night. It's spilling over in the mornings when kids are going to school, and it's spilling over in space. It's going to the coast. So the coast has started having basically exceeding this air standards as well. And again, these air standards are not great. They're something. it's way above them, sometimes an order of magnitude above them. Um, so it's too high. And it's shocking to me that it's being allowed to continue. I'll say that again and again. So just to remind you, this is raw sewage and industrial waste. It's got everything you can imagine. We are now, because nobody else is, we are now sampling everything. We're in people's homes. We're sampling the foam. We're looking at metals, the sediment, the air, the water. Um, we've got, sort of everything that we're looking into right now because we keep thinking, okay, what can we show that will make people realize this has to stop like yesterday? And the big goal right now, our next big surge is to link it with the actual health effects. If people are interested, we've just published a couple of papers, more papers on this topic showing, okay, so one thing that we get here back from the state is we can't help you because it's not one of those criteria pollutants, but it is affecting one of them, at least one of them is affecting the particulate matter. Because what happens is that cocktail of gases comes out and reacts, as is shown here. They're all gases. They react with the sun and they make particles. That's this afternoon haze you see every day over the ocean. So it is affecting that. It's affecting ozone levels. It's affecting NOx levels. So it is affecting the criteria pollutants, but that's not in any model anywhere in the world. And so, now we're working. Our biggest question is, how far is this going? Is it really just in the South Bay? We don't think so. We think this is a problem all up and down the coast. We have evidence that that's the case. We're hoping that the more people that see they're being exposed to this will help draw attention to this horrible situation. We're doing health effect studies. We're growing organoids, lung organoids, gut organoids, brain organoids, exposing them to the water and the air. And what I can tell you is even if you dilute things a lot, you destroy these organoids. This is just our way of testing something on something closer to what is inside of humans. We're developing sensors that we can place all around, lower cost sensors. We're working with, you may have heard of the ocean pathogen forecast model by our colleagues, oceanographers at Scripps. So our big dream is to actually be able to forecast this. Not say, oh, the air was horrible last night, right? We want to be able to tell people it's coming. And so to do that, we have to link it with where the pollution is going in the water and actually predict it in the air and create a public warning system and look at how far it really goes. And we have to think about this. This is not just a South Bay problem. So I think everybody's starting to wake up. I've been giving talks globally about this. There's other rivers that look this bad. For example, in India, Brazil, around Europe, everybody's pumping their pollution into the water. You can see it from space. This is SDSU's work looking at the wastewater plumes. So you can actually track it from space. And the point is that it's a problem that everybody has. Just nobody, I don't know, they just didn't pay attention. They certainly haven't linked it to the probably massive effect it's having on people's health. So we are going to do that. Our, sort of big picture dream is to figure it out where we are, to help. We don't want to give up till we figure this out, but then be able to take the way we sample, how we sample, what we measure, what health links we do, and look more on a global scale. Be using wonderful AI to do that, but to put all the water and air and health data and look for these trends to actually link air to health, which has never been done before, is going to take massive computing power. So the last thing I'll say is I want to thank the team that has been doing this. I have an amazing team. They're every bit as committed as I am. We care deeply about this community. We're appalled, and we're doing everything that we can to help. We have a ways to go. And again, I think this gives you a flavor of how we got here and where things stand. And I'm happy to answer any questions.
Wow. Amazing work, Dr. Prather. Any questions from the group? I have a few if you want me to kick them off. Yeah, I'm going to go ahead and kick it off. So, Dr. Prather, as a former Imperial Beach resident, one, I'm kind of happy I moved away from there, but it makes me nervous that things are moving as far as they are. I was really interested in your prediction model. How, if the worst times are tied to pumps. I think it's pump station Sila going down, or pump station 9 there.
There's one.
Is your prediction model going to be tied to that, or is it more just tied to the air and what's happening in the air at that time?
We're using it all. We have multiple ways of answering that. So, no one way works all the time because there's so many factors that control that. There's far more that controls sort of that overall concentration, right? There's boundary layer height. We also, I didn't say this, but we have sensors in the river. We put our own in there because
Oh, good.
so we've got sensors in the water so we can see when things are coming. We're going to put more further upstream. We're working with hydrologists. Actually, I see one of my favorite hydrologists is on the call, Mike Dettinger. But we're working with hydrologists to kind of try and link more of the water in the air. Um, and we do, yeah. I mean, knowing when that pump is on and off, I mean, that obviously is a key player. I mean, you can just directly correlate that, almost, but you still have to kind of track everything. So that
Sure.
is one piece of information. But the point is, if they're not going to tell us, which now I'm trying to like confirm my dates from our data and I'm not getting answers. So, we're just having to we're like detectives at this point, and we're having to figure it out on our own, unfortunately.
And the second part of my question is, with the super El Nino that's predicted for this year, your data says that you're seeing that the worst time is actually when the river's supposed to be dry, and that's when it's happening the worst. What do you envision might happen with the super El Nino in this year? Is that, I mean, we may not be able to, because it's such a because El Nino is going to be such a this one's going to be so powerful that we don't really know. But if you put out a crystal ball, what are you thinking?
I mean, as I mentioned, I mean, it's sort of a weird good news, but the good news is when it's so dilute by rain, there's going to be a lot of more damaged infrastructure, which is what they're blaming, right? So what I think is
Yep.
that the problem will be what happens when we have to go back to normal operation, then we won't have like they won't be able to turn the pumps on at all, right?
Yeah.
And that's my concern is when it goes back to or starts to go back to dry season. It's always March and April and May, and then people scream and then they turn back on that pump and then it goes down, right? So like I'm trying to say like the other thing I don't understand is why they do it always. You see them. There, someone's controlling those pumps. And so many people, why do you think that? I think they used to try to tell us it was controlled toilet flushing when everybody got home at night, which is like humorous to me, because it's so regulated. So why at night? And what I will tell you is we have hints on that as well because the water that's coming down in the nighttime is warm. So it's a warm, like cooling water. It's a significant source. And so I'm asking like the worst time you could like nobody's asked me, but I'll say it. Why at night? Why are the spikes? The worst air, the worst toxic air appears to be at night. That's when everybody feels it the most. It's because there's no winds, there's no sun to chew it up.
Oh,
And so
yeah.
it's just all trapped close to the ground. It's the worst possible time. So if you're gonna have to release whatever the heck you're releasing, do it in the day at least when it can get dispersed and diluted faster and it's not trapped where everybody's in their house locked in and breathing it. But
Yeah.
it's just such a weird thing because we just don't they don't ask us what any of this like when the pump should be on. One thing I will say, and you probably know this, is that they have gotten the money to flatten, like to get rid of that turbulent spot so that at least it won't be happening like right in the middle of the community.
Yeah.
But the best thing is just not to have the river there when there's not supposed. It was not like this when there was no river, and this all
Yep.
started sort of 2020, 2019, somewhere in there. There was a it was 2019, I think, was there was major damage. Um, and so what they do, and they admit it, is that they turn off their pumps to save them because of all the debris that comes. So right when they know
Yep.
there's a storm coming, they turn off their pumps. And then then they just don't turn them back on for months.
Yep.
And then, right, then it's like, then it just builds up and there's all this debris in there. And so all of that sediment and all that leads to bacteria building up and sort of this massive release of these gases. I mean, we've detected over 8,000 different gases coming out of that river.
Crazy. We've got a couple questions in the chat. Matt Dedinger, do you want to take yourself on off mute and go ahead and ask it
Mike,
yourself?
it's my
Mike,
hydrologist buddy.
sorry.
He's been teaching me about hydrology.
Oh,
Mike, you want to take yourself off? Go ahead.
sure. I'll basically just say that Kim just answered my question,
Okay.
which was, how long do you think this has been going on? Has there been a recent change in management or something? And as I put it
Yeah.
there, basically have whole generations of people in those communities been exposed this way, or is it more recent?
Yeah, it's like 20, it got really bad. We have it, I think in our science paper, we show that the flows all really started, the dry season flow kicked on around 20, I believe it started. I have to look at it, but it's like I think it became noticeable in 2019. Like it used to be dry, like it was supposed to be. And if it was dry, you wouldn't have this problem.
Yep.
And so I mean Mexico would, Mexico still would have the problem. And I want to also, since we're on this topic, there is a lot of finger pointing going on blaming Mexico, but we cannot forget that those are US 80% are US factories that are dumping God knows what. It's not
Yep.
toilet water into that river. We see everything. We see more benzene coming out of that river than you do next to a roadway. And that is a class one carcinogen. So they're dumping everything and with abandon. And so,
Yeah.
this question of like whose problem is it? And it's Mexico and we can't control it because it's coming from somewhere else. I'm not buying it because we shouldn't buy it because it doesn't, once it's here, you're supposed to protect your people. And there are ways to do it, not ask them to wait a few more years, which is what the answer they've been getting for many years. So yeah, it's a bilateral problem. As I say, I'm going down to Tijuana tomorrow. I'm convinced there's got to be people that think more like we're going to try and get water samples from over there so we can sort of do more source tracing. But it sure would be nice if we found a way to work together, and quit, this, it's not all Mexico, and we do need to work on this together. I believe strongly to solve it. And there's got to be people over there because if it's not bugging our people, if it's not hurting our people, when I say, oh, it's solved if there's no river, then it's on the other side. And kids over there, early birth rates, all the disease they have over there is even worse. And
Yeah.
so, yeah. Yeah.
Um, I don't know if you saw today, Dr. Prather, that Wild Coast, Sierra Club, Surf Rider, Four Walls, Supervisor Geary, and Assemblymember Alvarez joined together in a press conference to say no to USMCA until we get fixes because of those businesses that you're just talking about have been getting a free pass for way too
Yep.
long, and they've been taking advantage of the money that they make off USMCA and not doing anything about this. So, yep,
Yep.
that's one thing. All right. Next
Yeah, and there
question.
are, they keep talking about hundreds of millions of dollars, but like some of these things, like just fixing their damn pumps,
Oh,
right? So they
yeah.
don't have to turn them off. That's like so fast. And so like I don't understand. But again, it's like that's where we have to figure out cooperation. Sorry, but yeah.
Yeah. No, no, I totally agree. I have a question from Sabrina. Her question, Sabrina, do you want to ask it? Do you want to take yourself off mute or I can ask it? It's up to you. I'll do it. All right. Since this is a bilateral problem between Mexico and the US, can we make this a federal issue and claim it as an EPA Superfund site?
Yeah, we tried that. Um, in my view, it should be. It has every marker of one, but it didn't fly. It just keeps getting, I don't know if it's just, there's been a lot of discussion. There was a specific request for this. They said they looked into it, but you know, that's where I would argue. That's why we keep kind of measuring everything, including like the groundwater, because there's certain flags that have to be triggered. And what was happening was that the easiest way to not do anything is to not know what was there. And we've sort of made people more uncomfortable by, by making the measurements. Because, like when we showed the hydrogen sulfide was there, then they had to do something about it. Same thing for the Superfund. There's things that people look for example, in groundwater. There's certain things that have caught pathogens. There's certain things. And so we are continuing to look for the things that, could trigger that. I don't think it can be rolled out, is I guess the bottom line.
Next question, Martha's iPad. Do you want to take yourself off mute and ask it or have me ask?
Sure. I, don't we have some kind of infrastructure on our side? There's like some kind of processing plant
Yeah.
and there was they threw some money at it in the last couple of years. What's going on with that?
It's the IBWC, the wastewater treatment plant that's over here, and they have one on their side. And, they say they're starting to process more. But this gets back to when the water comes in, sort of where it goes. If it goes there, does it go in the river? Right. And so that's where things get a little wonky. They did throw more money at it. They say their capacity is up to, I think the number is
50 million
25
gallons.
million. Is it,
50 million.
it's up
They're
to 50?
supposedly
They're going to
they're
50.
they're going to 50, yes.
Yeah, they're trying to go to 50 million gallons. My concern about that is that's not the end because that does nothing to the chemicals, to the viruses, to like
Yeah.
all the, a lot of the metals, all that stuff. They don't, that's not what that's not what the processing is targeting. So to me, the number one solution is never put it in the water in the first place, right? Because like once the genie's out of the bottle, it's really hard to get her back in, right? It costs 1,000 times more at least. And so, that's the part I think just targeting those companies and really trying to get them to behave. And as I say, a lot of them are our companies. And so, just again, it just becomes an enormous, impossible almost problem once once you've poured it. That's just like the number one rule in any sort of environmental control is you just don't you stop it at the source, right? And so that's the best answer. But yeah, I mean we do have wastewater for the sewage part on this side and on the other side.
But
And they are
like
expanding their
Dr. Prather,
capacity.
the hotspot at Saturn Boulevard doesn't go to any treatment facility. That totally
That's right.
misses the treatment facility. So that's
Yeah.
those areas like that, and it doesn't. Punta Banderas it treats about 18. It's up to 18 million gallons capacity, but it is very. There's a lot of questions if it's even operating correctly. So
It's just running and it's not just turning on at night, it's running 24/7, dumping into the ocean. Yeah. Yeah, I
yep.
see a question about Department of Defense. That's a big one. You know, we are we are talking, we're just that's an interesting one because you would think, right, that would be the golden angle, that we should be protecting our military, because I think a lot, especially the Navy SEALs, the training facility. And they were worried about, when they just have a new facility, they have to get in that water, which is unbelievable. But they also breathe that air when they're all of our military are breathing that air. And I can't believe it's being allowed. And I can tell you, I've gotten a lot of I say secret phone calls of people telling me different, from the military, but they're not supposed to complain. So yeah, so I'm hoping that we can make a good, I have to believe there's a good connection of people that would care, and that would be a really important angle to get, because it is affecting there's no question it's affecting our military. It
If you
is
get
a
if you get
security
a
issue.
if you get a chance, there's a great 60 Minutes episode with Leslie Stahl. You might see this face on it that talks a little bit about that, because it has been something that the Department of Defense needs to be more involved in it, because it has gotten SEALs, and it's as we're fighting more wars, the SEALs are almost on the front. They're on the immediate of all of it. So yeah, so I agree completely. But you have to check out that 60 Minutes sometime. Okay, I got
Yeah,
another question.
we just have to find the right contact.
Yep.
I know they must exist, but so far the ones that we have talked to would have preferred not to talk
Yeah,
about it.
I
So yeah.
understand. John Knox, do you want to take yourself off mute and ask this question?
Yeah, sure. First of all, Dr. Prather, thank you so much for your informative presentation. I think I can say that although most people are aware that a problem exists, very few have any idea of how serious it is, and your presentation really conveys that. I'm just wondering about this. For those of us in the community that are worried about this, what are there any recommendations out there about what we can do as individuals to protect ourselves, our families from these pollutants when the levels are especially high? Should we be wearing surgical masks? Do we need air filters? Should we stay inside? What should we do?
Yeah, thank you for that question. We're working on this a lot, and air filters work. some people are skeptical, but we're about ready to publish a paper showing we've been working with schools, and we can take the levels way down, especially the viruses and the bacteria. The hard ones are the stinky gases. Although we are working with companies on developing the right formulations of sorbent tube, you have to get these, like, the gases, just the particles are easy. Particles, they're HEPA filters, they work super well. So if you don't want just, smoke and, sort of all the aerosol part, that's trivial, honestly. So yes. And the other thing to remember is we spend 90% of our time on average indoors. So we can clean our indoor air. Even if we can't help outdoors, we can clean indoor air. And so I have, I run filters in my house. All my friends that sort of live coastal bluffs, where they know there's pollution, a lot of them have allergies, they now have filters in their homes. Again, from sort of the allergy, aerosol, asthma sort of link. Now for the gases, it's more tricky. They are giving out filters. San Diego County is giving out more. Air Pollution Control District has been giving them out. The problem there is that they were too small. And so people are giving like one per home, and it's just not enough. But they work. They take out the gases. They don't 100% remove the gases. I'll say that. It's really hard to do that. But I always tell people the problem is these are really like hydrogen sulfide. Even if you had, like, say 1,000 ppb and you pumped it through and you took it down to 1 ppb, which is much better, right? You got rid of 999, which I'd much rather breathe 1 than 1,000, right? But at 1, it still stinks. So people are like, oh, they don't work. I still smell it. Yeah, you will still smell it, but you are removing a lot of it, right? So air filters are wonderful, and everyone should be running them. The question is, a lot of people don't like running them all the time, electricity concerns, things like that. So that's where we would like to be able to kind of help with forecasts and say when it's particularly bad. The other thing I will say, I can put it in the chat. We have real-time measurements. So the Air Pollution Control District will tell you, like, the next day what you breathed the night before. You can go to the site and we're measuring it constantly, and you can look and see what's in the air right now. And so you can kind of see when these waves are coming, and they come at the same time almost every night. So yeah. So in answer to your question, filters work. You can filter your indoor air. You just have to make sure you have the right size and right type of filter, but they exist. As far as the masks, surgical masks are meant, again, for particles, and they aren't as good for KN95s, the little ones that seal a little bit better if you wanted to not be breathing the aerosols, the viruses and the bacteria. They will work for that on an individual basis if you're outside. But it's not, what I will tell you, again, we were doing indoor measurements, and indoor is way worse because outdoors it kind of goes, it's like a big bathtub, right? It gets really dilute. Whereas inside, everything gets trapped. And people, because of the smells, are like taping their windows and doors shut, which is like not good, right? Because then it just builds. It's like, just pumping pollution into an enclosed bathtub. It gets really high. So yeah, short answer, yes, air filters do work. Get the right kind. We have stuff about it on it. I'm the director of an airborne institute. We help people all the time, advise people on how to make sure that their indoor air is the best it can be, because it's a balance, right? There's also ventilation, making sure you're not over breathing. You hear about carbon dioxide. That has that's what can build up indoors basically and affect your thinking capacity, especially in schools. It's been shown to lower test scores. So anyway, we're working with schools as sort of our demo, and we're about ready to publish a paper, but you can really see a huge effect on that in the houses that have the filters running.
A quick follow-up. Thank you for your response, Dr. Prather. Quick follow-up. We're not talking, the people who are at risk from these pollutants are not just residents of Imperial Beach, but we're talking to areas beyond that, Chula Vista,
Yep.
National City,
Absolutely.
Coronado.
Yep.
So it's people throughout the region. Is that correct?
Oh yeah. Yeah. And I have friends, I'm in La Jolla, right? UCSD's in La Jolla, and professors there that have serious lung and, respiratory and pulmonary issues. And they have like 6 filters in there. The only place they aren't coughing and sick is like in their homes, right? So, you think, it's a beautiful ocean, and it is a beautiful ocean, but there is things that can come out and cause, allergies and those kinds of things just, from the polluted water, which, in answer to your question, yes, it can get up that far. Not like every day, but we're now trying to understand that better. The model that I showed, the pathogen forecast model, goes up to like Coronado and then kind of stops. But now we're talking about how do we stretch that, because this is, I really do think it's the coastal waters, as we know, are more polluted. They just are. And so, this is a bigger issue than South Bay. South Bay, though, with, tens of millions of gallons of this stuff is particularly bad. But anybody living along the coast has to be thinking about what they're breathing.
Wow, it's incredible. Any other questions? Well, I want to thank you again, Dr. Prather, for sharing your expertise with us tonight. And thank you to everyone who joined us for this important conversation. The Tijuana River pollution crisis affects the health, environment, and quality of life of communities throughout our region. Events like this help us better understand the science, which you are so good at explaining there, Dr. Prather, elevate the experience of impacted residents, and build the public support needed to demand meaningful action. If you enjoyed tonight's Sierra Talk and value programs like this, please consider making a donation to the Sierra Club San Diego chapter. Your support helps us do this over and over again and organizing communities, advocating for environmental justice and protecting the places we all love. I do want to say next week, same time, we've got Dr. George Mott, who will discuss tobacco waste in the Kendall Frost Marsh and its devastating effects on the diverse wildlife in the Mission Bay area. So we want you all to come out and house cigarette butts, cigarette waste, and plastic pollution, what it can be done to help stop it. But Dr. Prather, it's always an honor to hear you speak. I think you have a great way of articulating this to where we can all understand it. Take a concept that, as somebody who lived in IB and saw the rooftops full of stuff that we thought was aerosol gases that had been back to solids, I'm just really happy that it's finally getting the attention it deserves. So thank you very much. I really appreciate it. Anything you need from Sierra Club San Diego, we've got your back, Dr. Prather.
Awesome. Thank you. Thank you so much. All right. Thanks, everybody.
Have a good
Have a
night,
good night.
everybody.
Bye.
Take care.
Bye-bye.
Thanks. Bye-bye.